Hello, Daniel. We are live. Hello, Mr. Daniel.
Okay.
We are live.
Okay. Fantastic. Um, hey guys. um, it's great to be here
Yeah,
again.
Mr.
This week
Daniel. We are
for
live for the ML class.
yeah. I can hear you. I can hear you. Okay. So hello guys. We are starting deep learning class. How has it been so far? I hope you've not been having issues. Let me just open to the comments and okay. Yeah. Hello. Okay, so I hope you guys have not been having too much of an issue. I expect if you're having issues or challenges learning, because it might take a little time to learn, but once you get a grasp of it, it becomes very easy. Um, Jane says she has been having issues. It's normal. Okay, so I expect that everybody has the collab. So I'm just going to hop on there right now, and then we could just kick start. Share screen. Okay, for this class, I would especially need you guys to come on board. I need somebody to come on board, someone, at least one person. So I need one person at least to come on board. Okay, if I share, so please just send your email so that you can get the link. Um, DL class is very complex. It's not very complex. It's a little complex, but it's understandable. Let's put it that way. It's understandable. You can understand it just with a little time when you go over it over and over again. Um, wow, you really can't do this particular um, course without the collab because the code is in the collab. So my co-facilitators would send the collab to you, and then you just have to open it. Guys, I think I remember seeing Olusegun in the previous class, so I expect that you have the collab. Please can you open it, and then Jonathan, please come. Yeah, Jonathan, please. I want Jonathan on stage. So Jonathan, please share your email address. I want you to come on stage. I know you have the collab, so I want to take a look at your collab notebook. All right, so I'm hopping on to share my screen. I'm expecting Jonathan in a few minutes. All right. Okay, so I should be sharing now. Okay, so again, I'll walk through it. So we've covered what this cell does. This is basically to just connect your drive to Collab because you would have the images in your drive. You have the images in your drive, so we need to connect your drive to the Collab so that it can collect the images or pull the images from there. Excuse me. Okay, so once you connect the images, or once you connect the Collab to your drive, Okay. You need to import your dependencies. I explained that dependencies are what helps you have access to other people's codes. So now that you understand the concept of classes and functions, these are all classes and functions. So all you need to do is call a particular class. You can see that this is a capital letter to show you that this is a class. This is a class. So once you get the class, you can now use the class for the function or use the functions in that class for your own code. Does that make sense? I hope that makes a little sense. But these are all functions that you're going to use for functions that do several things. Some of the functions help you handle numbers, convert image to numbers. So the functions help you generate more data. Some of the functions help you count the number of pictures in your folder, in your folders. So the functions help you build neural networks, different functions for different things, different libraries and different dependencies for different things. So in a way, you could think of libraries, dependencies, functions, classes as the same thing. For this class, imagine them as the same thing. As you go further, um, they will begin to mean different things. But at this point, imagine them as the same thing. So libraries are those functions you used to do several things, different kind of things, maybe to handle images, maybe to generate data or count images, whatever, or build neural networks or score your model, different things actually. So the next line is you need to create your train and validation directory, right? So let's connect and see. I explained um, where you can find, excuse me, your training and your validation. I explained how we've gone through the process of filling your training and training directory and validation directory with the images. We've gone through that process. If you don't know that process, please go back to previous videos. I think week one rather, week one. Okay, use data augmentation with the image generator API. So we said this is to help us create more instances of our image. So it would um, create some images that will be zoomed, create some other images that will be flipped, create some other images that will be rotated, create some images that will be skewed, right? And then we said this would help us turn the images into the numbers that our model can understand. Our model, mobile.net is our model, our pre-trained model. So this would turn it into a number. It's going to go through pre-processing. All the image will go through pre-processing. It will turn them to numbers, and then it's that number that will feed into our network. Remember, we've talked about that. And so once you create the class, you can see it's a class. It should be familiar with you now. This is a class, right? These are the parameters of the class. Do you see it? These are the parameters of the class. These are the values you're putting inside the parameters, right? Okay. And then you pass that into this variable here, all right? Train data gen. So train data gen, you're going to take this particular function, flow from directory, just like you took after you instantiate a class, you do in Python class, you do dot add, dot subtract, dot sum, dot a particular function. So this is a function inside this image data generator class, right? And this particular function takes in several parameters. So it takes in our training directory, it takes in the target size. This target size is what MobileNet can understand. I explained how it reduces your images sometimes is 1024 by 1024, but this would change or turn the image into 224 by 224. So that means it's going to make it smaller. A way to understand this is, let me see if we can pick this out. Yeah. So you can see this is 400 by 250. Let me see if we can. Yeah. Is there a 23? Let me see if I have another image. Okay, never mind. Just let's focus on what I wanted to focus on. So if it were, this is what it does. It turns your image from 1024. This is how your image comes in, or maybe some this large. Your image is this large, right? So the pre-processing would turn it into 224 by 224. It will make it into this size, into this small size, and then it will pass this into the neural network, into the mobile net, right? So that's what this means. That's what target size means. It means that you're supposed to convert the images, make them. If it's too large, it's going to make them into 224. If it's too small, it's going to make them larger into 224. That's what this means. Then batch size basically means how many batches should you train at once? We've talked about this. And then class mode means categorical or binary. Binary means you're doing just two classifications. So it's either a horse or a dog, or Jane or James, or just two classifications basically, either yes or no, right or wrong, cat or mouse. But for categorical, you have more than one classification. So you could be classifying more than 10 different people's images, right? So that's what this is doing here. Okay, we talked about this last week, and then we delved into a little more into MobileNet. What MobileNet is, how to fine tune it. Um, is Jonathan here? Hey guys, can you see the screen? Can you see my screen? Hello guys, can you see my screen? Okay, fantastic. Okay, so I'll just continue then. So we talked about fine tuning MobileNet. Why is Jonathan not here yet? Jonathan, I need you on stage. Okay, let me reshare. Okay, so I am. Okay, let me just quickly confirm with um, my co-facilitators. Okay, the link will be shared with you in a jiffy. Okay, so let's go back. We talked about. Um, okay, that means I should rerun this so that some people don't miss out. So I said target size basically means we're changing the size of the image into 224. And I give the example here that sometimes you could have your image coming as 1024, 1024. All right, so your image might be this large, right? So what that code does is it turns your image, it brings down the size of your image into this, right? And then feeds this into the neural network. Okay, so um, Yeah, so that's what's happening with that target size. I explained that categorical. I've explained categorical and I've explained batch size. So for fine tuning mobile net, I explained this last week. This is just to show that this is the size of image it's going to take in. I explained why this is three, and I explained what it means when it is one. Right, one means it's black and white. Three means it's colored. Right. If you didn't watch last week's class, you should go back to watch it so that this will make better sense to you. And then I explained all this. I explained what the layers mean and how they function. And then I explained all these lines of code. Okay, so I didn't explain optimizers, and I think I did. We explained optimizer, explained loss, and we explained metrics, right? So we're going to come a little lower today, and then talk about model.fit. Um, this is not very. This is fairly easy. Train generator is the images we stored here. So we've taken the images in our train directory. We've put them into 224 by 224 here. We are taking them in batches of 5, and then we're doing um, categorical, excuse me, categorical um, classification, right? And then we take all that, and then we put it the into the model here. And then we're saying we're going to train for 20 epochs. That means go over. Now, you know it's going in batches of 5. So we have about 20 images, I think. Let me see. Okay, we have about 40 images. So it's going to go in batches of 5s. So that means it's going to go 8 times. Okay, it's going to go 8 times. Okay, so Jonathan, you're on stage. Just give me a moment. Let me wrap this up. It's going to go 8 times. Um, it's going to train all through once. It's going to train five until it completes the whole 40, right? That's one epoch. Then it's going to go back again and do the same thing, 8 times. That's another epoch, and then it does that until it gets to 20 epochs, right? Does that make sense? It will train on first 5 images, next 5 images, next 5 images, next 5 images until it gets to um, 40 images. That's one epoch. Once it goes through the entire image, that's one epoch. Then to go again and that epoch until it gets to eight 20 epochs. Then verbose means how should it display while it is training, what should it show you. um, if it's training, if this is one, if it is set to one, it would not show you anything. It's called you're telling it to be silent, to train silently, but you want to be seeing the parameter, the metrics while it is training. So the metrics here is it started with about 61% loss, then the loss went down to 28, then the loss went down to 15, then the loss went down to 15, and then to 10, to 15, to 1, to 1%, to 7%. So you want to be seeing all this. That's why we set it to 2. So that means it's showing us the loss on the um, loss basically means the mistakes it's making on the training directory or training images, and then it's showing us the accuracies making on the training images. On the other side, it's showing us the accuracies, the loss is making on the validation data, and then the accuracy is making on the validation data too. That's what this is. That's what verbose is showing us. Then, of course, you have to pass in your validation data. I explained last week that that's how you measure. It measures its accuracy. I explained the whole concept in last week's class. But let me just quickly iterate through it or go over it again. So your validation data comes in X and Y, meaning in training image and label, right? So it's going to train on the training images. Then it's going to take the validation images. After it has trained on the training image, it's going to take the validation images, and then it's going to try to guess what the correct label is for every validation image. Now, but it's not going to see the label of that validation of the validation images until it has guessed. So once it guesses, it will now compare its guess to the correct label of that validation image. That's what's happening there. And so once it does that, it will calculate how correct it is overall, and then to show you the loss here, or the accuracy here and the loss here. Accuracy is how well it gets it. You can see that it's getting it every time. It's getting everything. This is 100%, 100%, 100%, 100%. It's getting everything almost every time. Um, and then it's making lesser mistakes as it goes on. That's what this means. If this is high, this is separated as, see this as 72.73, 81.82, 90.91. This is 100%. All right. And then callback just shows you um what it should, when should it stop. Now this is supposed to go 20 times, 1 2 3 4, but it went only 8 times. Why? Because we told it that it should stop the training when the validation loss does not, this val loss here does not change after 2 epochs. So we're going to be patient for 2 epochs. If it doesn't change, or if it doesn't get lower, loss is supposed to be getting lower. If it doesn't get lower after 2 epochs, then it should stop. So if you check it after 2 epochs, it didn't get lower. This at this point is 0.7, at this point is 0.5, so it did get lower. At this point is 0.1, 0.1. This is 11% rather. So it went from 5% to 11%. So that means it increased. And then it increased again to 0.20. This say it's from 11% to 20%. So this is the first one, this is the second one. It didn't get lower, so it stopped automatically. If not, we would have had to do it till 20 epochs. Okay, so we might want to test the classifier. All we need to do, okay, we've actually tested the classifier before. You could just run this cell, because once you have access to the Collab, you could just run this cell, and then you would see the classification. Please go through the class, the previous classes. It would help you. Take your time, sit down and try to understand it. It's going to take you some time to understand. It's a little complex, I know. It's going to take you some time to sit down and digest it. You can't just watch the video and understand it, and you have to practice. You have to break the line one by one to see what is happening there. And of course, I've explained them. That's the only way you can understand it. That's how you understand codes, right? Take your time to understand them. So I'm bringing Jonathan on board. So I want to see you share your screen, Jonathan. So yeah, Jonathan, I want to see you share your screen. Your collab.
Yeah. So Jonathan, you can share your screen so we can bring you on board. Please be first.
Jonathan, we're looking forward to seeing your collab. I want to see what you've been working on. I want to see the.
I'm sharing.
Okay.
I'm sharing already.
Okay, fantastic. Okay, so you can just can you scroll? Okay, this is the beginning, yeah? Have you mounted your drive?
Yes, I have,
Hello.
but
Okay.
I'm running into some errors. I don't know. Oh,
Hello, Jonathan. We can't see your screen. We've lost you for a moment. Hello, Jonathan.
Daniel, I think you should just continue until when he's ready.
Okay.
Yeah.
All right then. So, oh wow. Okay, that's fine. As soon as you get it up, just let us know. Okay. So let's run all this and see what happens. Our drive is mounted. You can see the code is already ready. My images are ready. You can see the images here. Right? The images are ready. So it just goes there to fetch the images. That's why I could just click it. Again, if you don't have your images, please refer to week one's class. You would see how to get the images. Um, okay, okay, okay. These other cells were used for explanation, so I'm just going to skip running them. We don't need them. Okay, and then we're going to start training. So it's going through those images in batches of fives. So 5, 10, 15, 20, 25, 30, 40, 40, 35, 40, and then to finish the whole epoch and start all over again. So it has gone through one epoch here. It has gone through another epoch. Our model is performing very poorly. How do I know that? It's having an accuracy of 54% here, 54% here, 54% here, 54%, 45%. It's supposed to increase, not reduce. The previous one we did had about 100% accuracy. Now this one is having 45% accuracy. So something is wrong. That means we have to go back and find what is wrong. It's not performing well. And I presume it's from here. So let's try changing this to 5. So that means we're training everything up until the last 5 layers. That's what this means. So let's see. Let's start all over again and see. Something is not right. It's performing too badly, too poorly on the validation data sets. But it's performing very well on the accuracy on the training data set. Something is wrong again. So let's see. Because they have to increase at the same level. They shouldn't be too far from each other. Oh, okay, it's increasing. It's increasing. 72, 63. Something is not right. Okay, so let's go back again and see. What can we do? Let's change the learning rate. Let's reduce the learning rates. So this is in case it's not performing well for you. Okay, so you just tweak parameters little by little, right? Change just one thing and see what effect it has. Let's factory reset. Let's compile and then let's see. I must have tweaked something when I was doing explanation, but it's fine. It's a learning process. So let's see how we can improve on it. Okay, so apparently this has a very bad. Let me see. Mm, Again, there's a lot of experimentation when you're building your model, finding the optimal model. So let's try again. You'd have to keep doing this to find the optimum, your best performing model. Then I'd like to see the data it's referencing. Let's check the data. The problem might be from data. Recognizer. Okay. Okay, it's a facial image. Okay, our data looks good. Our data looks good. Okay, let's check to see. Test. Looks good. Looks good. Okay, so our data doesn't seem to be the problem. So it has to be from our model. This looks good. This looks good. Why don't we do 6? Let's try 6. This has to be from, let's make it 15. Let's try 6. This is the point where um this is the point where the, should I say, issue is from. So this, you'd have to select an arbitrary figure here. There's a way to actually be more precise, but it's a very long process and beyond the scope of this course. So you have to try different figures to see which of the figures work best would work best for your particular data. I want to train continuously. In fact, I don't want to stop. I want to continue till it gets to 20. So let's train some more. Okay, so it's beginning to perform well now. Accuracy is getting to 100% and staying around 90%. Loss is reduced to about 14%, 6%, and we have that at around 7. Yeah, we have that at around 17 epochs. Remember, we had already trained for 4 epochs. So this is actually starting from 4 epochs. This is the fifth epoch, 6 epochs, and then down to 17. So this is around, say, 20 epochs before it begins to perform well. So what we can do is we will now restart the run time and run for 20 epochs. This was faster, but I think I missed the right figure. um, but we could still make it work. So we're going to run for 20 epochs without stopping it. Okay, starting at 45. Let's see. Wow, 95% accuracy on training data. That's pretty good. The validation loss is dropping, which is good too. And validation accuracy is increasing. Good, fantastic. So this is why sometimes you want your verbals to be two, so you can actually inspect. Oh, okay, we're hitting 100 epoch 8, as at epoch 8. Okay. At this point, it's basically your model is already too good. Okay. So now I believe the model is this is the right parameter for it since we're doing around 100% accuracy. So our model is good enough. So this is the right parameter. So again, I would have to reset and then add back our callback to it so that it stops once it gets to once the validation loss doesn't decrease. So let's just run it one last time and then test it out. Oh, would have an error. We've not. It hasn't been compiled. Would have an error. I missed that. So I'll just So let's compile it. You have to compile the model first and then run it. While it's training, let's prepare um, the data for tests. Okay, so this function basically takes the image file. That's the name of the image. In this case, we have the name to be, let's see, we're going to the test folder. Okay, let's test for Jennifer Aniston. Okay, so first I want to take this copy path and replace it here, right? So this is Jennifer Aniston. Then, so yeah, once it comes into this folder, it goes to the folder here. Then it adds the name, which is for example, 16.jpg. It adds that name that's what this means. This image path here plus the image file, which is the name we're going to pass in here. This is a function, guys. We just finished talking about it, so it should look familiar. So we're adding the image name to the image path, and then we're changing the size to be 224 by 224. Remember target size, we've talked about it. And we put that into the image, right? And then we turn the image into an array of numbers. Remember, it's numbers we feed into the neural network. Neural network doesn't understand images like we do. What it understands is numbers, right? So we're turning that into numbers, and then we're into an array. That's what this means. That's what this is. So we're turning it to an image array, and then we're expanding it. Don't worry about this. The idea is you're just expanding it so that the mobile net can take it in here, right? So once we do that, that means we've prepared the image. Let's check out the particular image we're checking. So let's check 22. Let's check 22. This is the image for 22. All right. So now we're calling the function. This is the function prepare image here. I should just take this up. Yeah. So now we're calling the prepare image function. We're passing in 22.jpg. It adds that to, oh, okay. Let's not use 22. Let's use 20. In this case, let's use 20. So we're testing for this particular image. Yeah, we're testing for this particular image. So yeah, we're saying model, we're calling the model we just trained up here. Model, after fitting the model, we have to predict. Predicting is how the model tells us what it thinks after it has been trained. Fitting means we're training it. Predicting means we're testing the model, right? So we've pre-processed it. Remember, you're returning. The concept of return is you're taking whatever output is here and you're putting it into this processed image, right? And then your model will predict pre-processed image, right? And then it gives you this prediction of, I believe this should be, let's see, of Chris and what's the problem now? No such file in directory. Are you sure? Let's add this and see. Okay. So yeah, so this is Jennifer Aniston and this is Chris. It's about 99% sure that this is Jennifer Aniston. 99.9% sure that this is Jennifer Aniston. It's 0.07 blah 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 percent sure that this is Chris. So that what you need to do is you need to now take in the primary or the larger number. So since you know this is for Aniston, you're saying if the max index, that's the max index of this list, the highest number of this list is the first item, the first index. This is the mass number of the list. This is the first index. So you're saying if the max number is the first index, which is index 0, right? Print that this is Jennifer Aniston. Else print that this is otherwise print that this is for Chris Brown. This should make sense if you've been following Python class. All right, so it's telling us this is Jennifer Aniston. So our model works beautifully. Let me just quickly get back to Jonathan so I see whatever error he's having. So Jonathan, yes, please can you share your screen quickly? If Jonathan is online, please can you share your screen so I can quickly see the error you're having? Okay, so I'm assuming Jonathan is not online. Is not on stage yet. Okay, so Guys, if you're having any issues, please don't hesitate to reach out to me or send an email to Coderina, hello@coderina.org. I'm looking forward to Jane. Please send an email so we can help you out with the collab. Um, Shegun, you've not said anything throughout, so I don't know what level you are, what you've done, what you've not done. Mensa, how is it going for you? Have you been able to implement any of these? Um, Jonathan, I was looking forward to seeing your screen, but it's fine. All right, guys. So I'm looking forward to next week's class. Next week's class with you guys. Again, try it out with different images from maybe your image or your family's image. It's supposed to be your project for this course. All right, guys. Have a wonderful, wonderful weekend.
So can I know that now? I've been trying to
So Jonathan, we can see your screen. Can you explain to us what you've done? No, Jonathan. Okay. I hope we've all had fun during the course of this program. It's been fun all along, anyways. Um, at this junction, it's going to be the end of week 4, and I'm so excited that we've achieved a lot in week 4. I'm hoping to see all of you back in week 5. It should be bigger and better. And whatever assignments slash questions and
I was
clarifications that
trying to share my screen in class.
you have, the clarification to help all, and we'll be able to answer all of your questions. So, there are no further questions here. I hope we've gained something today. Okay, fine. So, there are no questions. I'll see you guys next week. Same time, same venue, same place. Like always, we send you the timetable and the link that you'll be able to use to connect. See you guys soon. See you guys next week. And bye bye, everybody. Stay safe and stay healthy. Bye.